so the next step in the process is finding your vertices of your feasible region, which is your overlapping region of all your constraints. Another way to say that is solving for your intersection points, because it's going to be two lines crossing that represent the vertices of your polygon or of your feasible region. So it's going to be really helpful to have Desmos up of your graph. Okay, remember I showed you in that last video that you can, yes, I know you can see your vertices right here. Desmos does it for you, right? But if we didn't have Desmos, okay, we need to be able to figure out how we can do this by hand. So we're going to prove Desmos to be true. So like, how does Desmos know that this just happens, right? How do we type these lines in and get those intersection points, all right? So how you're going to set it up is with a system. So right here, and notice I've changed all my colors for each of my constraints to be a different color, because for this step in the process, it's going to be easier to figure out which two lines are intersecting if they're different colors. All right, so we solve for intersection points by setting up a system. All right, so here, notice I have my orange line crossing my green line. So I need to grab my orange equation and my green equation. I know these are inequalities, but for the sake of solving for this system or the intersection point, we're going to actually change these to equal signs, because really an equal sign represents a line, and so two lines crossing, we can just change those. The inequality represents the shading, and if we're just solving for this point, we don't need that, okay? So orange crossing green, so I need my 3x plus 5y. Y'all can write that down as I write it, and I'll switch it over in a second. 3x plus 5y equals 540. And then my green line will just be x equals 0. So let me minimize this for you. So that should be the setup for 1. Okay, so this represents your first vertice. All right. I'm going to go back and solve all of these, but I want to set them up first, because the students who feel really good about solving systems, I just want you to see the setup of it. Then you can stop watching the video and go and do this for your problem. All right? I don't want to waste your time there, but I will solve all of these at the end. Okay? So system 2, all right, over here, to represent vertice number 2. Okay, let's do... We'll just go around kind of the polygon this way. So this one over here, okay. Orange intersecting blue. So these two right here, right on top of each other. So 3x plus 5y equals 540. And then the blue line is 15x plus 8y equals 1800. Okay, then... Here, I'll let you see that, just to make sure you wrote all your numbers right. So that would be orange intersecting blue. Okay, those two. And that represents the second system, okay, or your second vertice. All right, then we have this one down here. So what is that? Blue intersecting purple. So my blue line is the 15x plus 8y. I'm getting them again from over here. So this is my blue one. So 15x plus 8y equals 1800. And then my purple line is y equals 0. And then this one, how easy. This one is green intersecting, oh, let me minimize that. There's that third vertice here. Okay, and then this last one, you'll see if you haven't already why this one is so nice. This system is already solved for you, because notice it's green intersecting purple. And look at these, x equals 0, y equals 0. Okay, so we already know that vertice. X equals 0, y equals 0. That's your system. So that vertice, or that vertex point, would just be 0, 0. Okay, because we know what x is, but we know what y is. All right, so that's the setup of it. All right, guys, so now you're going to do the same for yours. Go find the vertices of your shaded region, see which two lines are intersecting, and now you're going to solve your system. Okay, so whenever you solve for x, you already solved for y, then that represents your vertice of your intersection point. and that's how you'll verify that Desmos came up with the correct vertices. Okay, so you have to have your work to prove it. All right, this is the only one I guess you don't need work for. All the other ones, even if it is simple like these two, you'll see aren't that bad. Still show me all your work so I know that you understand the process of it. Okay, so those of you who are good with systems, you are good. You can pause or stop the video and start working on yours. Okay, others of you who want to see me go ahead and work these, I'm going to go ahead and do that so then you can get just another systems review. Okay, so I'll start with equation 1, or system 1. So that is your 3x plus 5y, and you don't necessarily have to rewrite yours if you have room, and then x equals 0. Okay, so you can either use elimination or substitution in order to solve your system. Okay, this one, since you already know one of your variables, we already know x is 0. So off to the side, we know that this vertice is 0 comma something because we know x is 0. So here we're going to use substitution. There's really no point in using elimination because we know that x is 0. So what you can do is substitute this into your first equation. So you'll have 3 times 0, so you're substituting that in for your x, plus 5y equals 540. So you're using substitution, right? So then 3 times 0 is 0. So you're just left with 5y equals 540, and then to get y by itself, we'll divide by 5. Okay, so then you'll do 540 divided by 5 and get 108. So that's my y-coordinate of the intersection point. So my vertice there should be 0, 108. And then check with Desmos. I'm cool with y'all. As long as you have the work, the math work to prove it, use this to make sure that you got it right. So we can go up here, click that vertice, that vertex, and notice it says 0, 108. So we proved Desmos to be right. Okay, so now I'm going to go ahead and jump to equation 3 because it's very similar to this, or system number 3. It's very similar to what we just did. So 15x plus 8y equals 1800. And then this time we know that y equals 0. That was the second line. So same process. We're going to use substitution because we already know that y is 0. So we already know the y-coordinate of the intersection is something 0 because this is the y-coordinate. All right, so now we're going to substitute that in for x. So we'll have 15, or no, we're solving for x, I'm sorry. So 15x plus 8 times 0 equals 1800. Okay, and then we're going to go ahead and solve. So 8 times 0 is 0. So that cancels, and we're just left with 15x equals 1800. So then you'll do 1800 divided by 15. X equals 120. So your x coordinate is 120. Again, you can verify that on your graph. So now I'm looking at this one down here because it's blue and purple. And notice it's 120, 0. So we did that right. Okay, so now let's look at the second system. So that 3x plus 5y equals 541. I ran out of room, so I have to rewrite it over here. And 15x plus 8y equals 1800. All right, so on this one, it's going to be easiest to use elimination. Okay, so elimination. So what you're going to do is look, you're going to align your variables, okay, and see if anything automatically cancels when you add or combine those equations. They don't, right? This adds to be 18x, that's 13y, nothing cancels. So what that tells us, we have to multiply one of our equations by a factor in order to get the equations to cancel whenever, or one variable to cancel when you combine it. So I'm looking at this 3x and this 15x, and you always can start with your smaller number and say, is there something I can multiply this by to get this coefficient? Notice the 5 and the 8 would be annoying because there's nothing you can multiply 5 by to get 8. So if you were to eliminate your y's, you would need to multiply your equations, both of your equations by something. Okay, so like you would have to multiply this one by like -8 and this one by +5. So if that happens on yours where neither of your variables, you can take the smaller coefficient and multiply it by something to eliminate, you're going to have to multiply both of your equations. All right, but here, notice if I multiply by -5 and I distribute that to all my terms, and then what you do to one side, you do to the other. So I have to also multiply the 540 by -5 to keep it balanced. So -5 times 3x is -15x. -5 times 5y is -25y. And then 540 times -5 is -2700. Okay, and then I'm going to just rewrite this second equation underneath. So 15x plus 8y equals 1800. So now, and this hopefully, if you're confused why I multiply by -5, maybe you're seeing it a little bit better here. Because now look at my x's. Now when I add them going down, you see how when I try to combine them, they're going to cancel. And that's the whole purpose of elimination, is to eliminate one of your variables. So now let's combine these. So -25y plus 8y is -17y. And then we're going to combine this. -2700 plus 1800 is -900. All right, so then obviously last step would be to divide by -17. So y equals, and when you type that in, okay, you're going to get a lovely number. But remember, my problem, I'm dealing with acres, so I can have like half an acre, quarter of an acre, I guess 0.941 of an acre, okay? If yours comes to a decimal like this and you're working with people or cups of coffee or horses or whatever, okay, go ahead and round out. So 52 point, I'd round out to like at least 3 places. The further out you round, the more accurate your answer will be whenever you go to take this and solve for x. But whenever you go to write your final answer, if this happens to be your final answer, you're going to want to consider if you need to round up or down depending on the problem, okay? So just keep that in mind. For now, go ahead and keep the round out to like 3 places. Don't round to the whole number yet. All right, so now that we have our y coordinate of our intersection point, we need our x coordinate. So you can plug it into either one of these original ones. It doesn't matter, because keep in mind, right, those are 2 lines crossing, so they're going to share the same x, share the same y, so it doesn't matter which one. I'm just going to go for the smaller numbers, but it doesn't matter. So 3x plus 5y, but instead of y, we now know what y is. So 5 times 52.941 equals 540. And now I'm just going to be on a mission to solve for x. So we can do 5 times 52.941. So 3x plus, when you multiply those together, you get 264.705. Okay, so now subtract over your 264.705. Okay, so we'll get 3x equals 275.295. And then divide by 3. So x equals 91.765. Okay, but again, we solve for our intersection point, so we want to write this as a coordinate point. So put your x-coordinate first, and again, that's your vertice, our last vertice that we needed, comma, 52.941. Okay, and then we can check to see in Desmos that these lovely numbers match. And so that was here, that blue and orange system. And so notice we get 91.765 and 52.941. All right. So that is how you can solve for each of your intersection points and prove that Desmos did find them correctly for the next step in your process.